Hello everyone, hope you all are doing well. So now we'll start up a new topic, that is quantum numbers. The quantum numbers, the word quantum means the energy values of the numbers. Okay, and the quantum number tell us the information, the position and the location of the electrons in an atom. So let me write here, tell us the information, position, location of electrons in an atom. After that, let's move towards, there are the four quantum numbers, but today we will just talk about the two of them. Four quantum numbers, okay, and these are denoted by M, L, N, N, L, M, S. So we will talk about number one quantum number, that is principal quantum number. Okay, number one is called the principal quantum numbers. Okay, principal quantum numbers is denoted by N. Okay, after that, these numbers contain the natural numbers, or you can see the positive numbers. So we can write over here that N is equal to positive numbers 1, 2, 3, 4 and so on. Okay, and these shells are indicated by, and this shells are indicated by K, L, M, N. Okay, and this will be capital letters. And after that, basically there are the two sides, as I didn't told you, it describe, the main thing is that it principal quantum number describe the size and energy. Okay, let's move further. Here will be the small size is equal to 1 and the large size is equal to 7, from 1 to 7. Okay, and these number of electrons in an orbit determined by, means calculated by, I should write here, number of electrons in an orbit calculated, or you can write here determined by, here is a one formula to determination of the, here will be determine, so the number of electron in an orbit is determined by 2 and power 2. 2 and power 2 means the second electron. Likewise, we are having the second shell having the 2 electrons, first shell having the 2 electrons. Okay, so like that to find the number of electron in an orbit means how many electrons are there in an orbit, we can determine that with this one formula, that is 2 and 2. Okay, let's move further. We are having azimuthal quantum number. Okay, second principle is, this number is called azimuthal quantum number. Okay, and these quantum numbers is represented by L. It's represented by small l. Okay, let's move towards it. Okay, it describe, you can write here, describe the shape of orbitals. What it describe? It describe the shape of the orbitals, that which shape it contain. Okay, so here will be the values of L, like value of L, if the value of L is equal to 0, okay, then it denoted by P. If value of L is equal to 1, let me copy it and then paste in all, paste it paste it, okay. So it will be p, sorry, not p, when it will be in 0 when the orbital is when the L is equal to 0, so orbital called s, okay. When L means azimuthal counter number is 1, so it represented by p. When it's got 2, it represented by d. When it got 3 means value of L azimuthal number, wait, just what I am doing, yeah, so it will got 3, so we are having S P D, and then we are having F shell, okay. On value of L it's 0 is S, then P D F. So azimuthal number describe the shape of orbitals that are S, P, D and F. Let's move further with these numbers. How we can maximum number of electron in a given subshell, how we can find the maximum number of electrons is given in subshell. How we should know that how many number of electron is given in subshell, means in one shell? So the formula is that the 2L, not 2L, it's 2L plus 1, okay. So if likewise I have written here that L is equal to 0, now we should know that how many electrons are there in S shell. So we will put the value of L over here, like we are having L is equal to 0, so we will put 2, okay, multiply by 2, then L we are having 0, so it multiply by 0, and then we have plus and then 1, okay. 2 multiplied by 0 means this 2 multiplied by with 0. Here we can see over here that this 2 multiplied by 0, so 2 zeros are 0, but 2 ones are 2. So here what will come over here? Here will come 2. So it means in S shell there are the 2 electrons. So same as in P, D and F, we can find the each of the electron, that how many electrons are there in their subshells, okay. After that there is one more method to find these subshells, like we are having K, L, M, N, okay. We are having these spots in this shells are indicated. Now how we should know that means how many subshells are there in K, how many subshells are there in L, okay. So what we will do, one thing, like here another way we can write here, another way to find subshells, means in that one we find the electrons, but in this one we find the subshells, that how many subshells are there. Like number, n is equal to number, means we are taking number L, okay, n is equal to L. This is a L shell, means the second shell. Like here after K we are L, then M and then N. So we have taken L, means we want to find the L shell subshells, that how many subshells are there in L shell. So we know that L is on second number after K, and then we will put over here L, and we also know that we are having a pairs of the electrons in that, like 2, 8, 18 and 32. So we know on second number we are having 8, so here will be the power 8, okay. We'll put power on 8. Now what we will do to find that how many subshells are there, so we will do one thing, that we will write here two names, like S, okay, then comma, then P, say, and after like we have put SP over here, so here's a 2 and 2 with this, okay. So what we'll do, we'll put 2 over here and 2 over here, okay. Now here this one 8, the 2 is the number of shell, L is the name, and 8 is the electrons of the number, means how many electrons are in L shell. So we'll divide this one 8 electrons in this both, as we know that we are as we have find over here that maximum number of electrons. So in S shell we know the 2 electrons. If we will find P, here we will put at the place of P we'll put 1, means L is equal to 1. So we got answer 6. Then we put 2, we got answer 10. So we put again, so we got answer 18. Okay, so like that manner. After that, now what we will do, that now we know that how many are there. So we know that in a L is equal to 0, in S shell there are 2 electrons, so we'll give 2 electrons to this. Wait, here we have given 2 electrons to this, 2s2. Okay, after that, now what we will do, like to find the electrons of P, we'll put 1 over here. 2 ones are 2, 2 plus 3 no, 2 3s are 6, yeah, 2 ones are 2, 2 plus 1 3, 3 2s are 6. So here P shell there will be 6 electrons. So what we will do, we will directly put power 6, power 6 to power 6. Now it means in the shell of L there are the 2 subshells, that is S and P, because 2s2 and 2p6, these subshells contain a one shell that is called L shell. In this manner we can find also M, N, like this all. Like we know that L is coming on now we can put 3 K, L is number on 2, coming on number 2. So M is coming on number 3, so we'll put number 3 over here. We know that 18 electrons are there. We know that 18 electrons are there in third one, so we'll put third is equal to, now what we will do, that we will just give them a numbers, like as I told you that how to take out these numbers, like 3s2, okay, then 3p, then we are having 3p6, these are 8. Now we are having 10 electrons are remaining of M shell. So SPD, I told you that how to find the electrons of SPDF. So here we'll put 3D, means the third shell, third subshell, so means the third shell of these subshells. Now 3D, so we know that the 10 is remaining, so we'll put 10 over here, because we know there are the 10 electrons in the D shell. So now you can see that 10 plus 66 plus 2, that got 18. So here 18 we have divided into 3 subshells. So it means that in third one shell there are the 3 subshells, that is PS, P and D. Okay, after that there is one more method to find the subshell of the orbits, means that what are the subshell, like another way, one more way. So I should write again that another way. Okay, now we will do another way, and this one what will happen there, here we will use value formula, that is L is equal to 0 to n minus 1. This is the formula, or you can also put comma at the place of 2. Now if we want to find the like here we find the subshell of L, means number 2 orbits. So we'll put again here the numbers of the orbits, like L, all things will remain, we'll just change the number of orbit. L is equal to 0, now put comma at the place of 2. Now N we are taking second orbit. Okay, second orbit minus, here we'll do 1. Okay, we are putting the number of second orbit that we are finding from second orbit. So we will put here L, just wait, is equal to, now we put here 0. Okay, after 0, 2 minus 1, we are having 1. It means L is equal to 0 comma 1. These are the electrons of the subshells. So we know that the 0 electron means L, if L is equal to 0, so it got S, if L is equal to 1, so it got P. So we will put the same, exchange the values of this, means L is equal to 0, so it means it's the S subshell, P is equal to 1, L is equal to 1, so it means it's the P shell. So here we know that how we can find the subshells of the orbit. There are the two methods. One method is this one, in which we can find also the electron of that, and second method is this, like in the second orbit. Now we know there is a 2 subshell, that is S and P. We can find others also like this one method. Hope you understand today's lecture. Thank you so much for listening.